Hello friend, welcome again. Welcome to everyone. My name is P.B. Prajapati. I am lecturer in applied mechanics. I am working in government polytechnic since long, and I am teaching this subject also since long. So in the previous lecture we discussed Lamy's theorem, which is applicable to three coplanar concurrent forces which are in equilibrium, and we see the statement, we derived the Lamy's theorem, and we also see the problems using Lamy's theorem. Now continuing that Lamy's theorem and solving more problems, let us take this problem. So here a body weighing 1000 Newton is suspended from a vertical wall. That is here it is weight 1000 Newton suspended from the wall, vertical wall, by a string AB which is 2 meter. So here string AB is 2 meter as shown in figure. It is pulled by a horizontal force of 160 Newton. Find tension in the string and lateral displacement of the body. So here this string AB is 2 meter long, force applied at point B horizontally 160 Newton, and unknowns are, here is the tension in the string AB and also displacement, that is this point B is displaced, say how much distance. So here said it is being displaced by a distance x. So this we need to find out. So first of all, let us find out the tension in the string, and for that we need to draw Freebody diagram at B. So at B we'll have three forces, 160 Newton, 1000 Newton, and unknown is the only T here, but also this angle is not given. So first of all we need to find out angle. So finding that angle, here in this figure we can see, or let us say this angle is theta with horizontal, that the string which makes with horizontal. So applying Lamy's theorem, then T divided by sine 90, because between this force and this force angle is 90 degree. So T divided by sine 90 is equal to 1000 divided by sine, we have taken this force, so angle between T and 160 Newton is sine pi minus theta, because here we have taken this as theta, so this angle makes linear pair, so that would be 180 degree or pi minus theta is equal to 160 Newton force divided by this angle total between T and 1000 Newton. So this is sine 90 plus theta. So here in this formula written, sine 90 which is equal to 1, so T by 1 which is equal to 1000 divided by sine 180 minus theta, that will give you sine theta, because sine pi minus theta or 180 minus theta is nothing but sine theta, which is equal to 160 divided by, here it is sine 90 plus theta or pi by 2 plus theta, so function will change from sine to cos, so it is sine pi plus theta is written as cos theta. And then we are having these three ratios, this equal to this equal to this. So from these 2 plus 2 equality, considering this last 2 equality, and in place of sine here in the denominator, if we write in the numerator here, so sine theta divided by cos theta is equal to 1000 divided by 160. Sine theta by cos theta is nothing but tan theta, so tan theta is equal to, we can write as 6.29. So theta will be equal to tan inverse of 6.25, which is giving angle theta as 80.91 degree. So here this angle can be calculated using Lamy's theorem here, because two forces are known So unknown angle we can find theta using Lamy's theorem. Then finding tension, then we can put that theta which is determined here. So T is equal to 1000 divided by sine theta, which is 80.91. So 1000 divided by sine 80.91 will give you T is equal to 1012.72 Newton. Now finding displacement of this point B from the wall. So this displacement is x. So here in this triangle ACB, here we need not to use Lamy's theorem because it is simple geometry, and in this triangle if we take cos theta, then cos theta in the right angle triangle is nothing but adjacent side divided by hypotenuse. So in the triangle ABC, cos theta is equal to adjacent side, that is x, divided by hypotenuse, which is 2 meter, that is 2. So cos theta is equal to x by 2. So from this, and theta we know it is 80.91. So cos 80.91 is equal to x by 2. So unknown x would be equal to 0.316 meter. So this is how we can find the displacement. Then here in this problem, a smooth cylinder of radius 1.5 meter is lying in a triangular groove, one side of which make 15 degree angle and the other side 40 degree angle with the horizontal. Find the reactions at the surface of contact if no friction and weight of cylinder is 10 kilonewton. So here this cylinder is resting in the groove. Here this side of groove is making angle with horizontal 15 degree, while here this side of groove making angle with horizontal 40 degree. And so this sphere is resting, this cylinder is resting in the groove. So on this side will give you the reaction. So reaction which is coming perpendicular to that face, that is RA, say, and here this cylinder is in contact with this side at point B. So at point B, reaction of this side would be perpendicular to that, which is given as RB. So drawing then Freebody diagram here, showing two reactions given by two faces, that is RA and RB, and weight of that cylinder already 10 kilonewton vertically downward. And from these angles, this angle with angle of this face with horizontal is 40, but this reaction is at the 90 degree angle to that face. So angle of this reaction RB with horizontal will be 90 plus 40, so it is 50. Same way here for the reaction RA, here that face is making angle 15 degree with horizontal. So this reaction which is 90 degree angle to that will be equal to 90 minus 15, which is equal to 75 degree. Then we can have angle between all these forces. So between RB and 10 kN force will be equal to 90 plus 50. Here in case between RA and 10 kN will be equal to 90 plus 75, and between RB and RA will be equal to 40 plus 15 degree, that is 55 degree. So then using Lamy's theorem, here say RA, then RA divided by sine this total angle, which is 90 plus 50, which is equal to 140, is equal to RB, then this angle which is 75 plus 90, that is 165 degree. So sine of it is equal to this force 10 and this angle total 55. So sine 55. So from this we can have reaction RA which is sine 140 by sine 55 into 10, giving 7.84 kN, and reaction RB sine 165 degree divided by sine 55 degree into 10 will be coming out as 3.15 kilonewton. Here in this example, a wheel of 10 centimeter diameter. So here is the wheel which is having diameter 100 centimeter and weight 500 Newton is resting against a block of 25 centimeter height. Find force P at the angle 45 degree with the horizontal when the wheel is just on the point of climbing the block. So here this is the wheel which is to be climbed on this block. So here when it is at the verge of climbing this block, it will give you reaction. So reaction R here will be in this line, and already force P which is to be applied here. So applying Lamy's theorem, and angles here in this case, this angle is say theta. Here diameter is 100 centimeter, so radius of this cylinder will be 50 centimeter. Block is of 25 centimeter, so this height is nothing but 25 centimeter from center of the cylinder to this point. So using sin theta, then sin theta will be equal to, sin theta is equal to opposite side divided by hypotenuse, which is equal to 25 divided by hypotenuse, that is 50 centimeter. So theta is equal to 30 degree. So this angle, that is angle of this reaction with horizontal, is 30 degree. So this total angle will be 30 plus 90, that is 120 degree. And here this angle 45 degree is already given because P is at angle 45 degree. So you are asked to find out force P. Then we have P divided by sine of this angle, that is 120, is equal to R divided by this angle 90 plus 45, that is 135, is equal to 500 divided by sine 500 divided by sine this angle, that is total is 105 degree, because this is 45 degree, this is 30 degree. Deducting this summation from 180 will be equal to 105 degree. Then solving this, we will get P is equal to 448.29 Newton and R equal to 366 Newton. And suppose in this case you are asked to find out this minimum force P, then what we have to do? We will have to take angle of P with reaction R 90 degree. Then we will get value of P as the least or minimum value. So in that case, this angle between R and P will be equal to 90. So rest angle will be this angle remains same, 120, and this angle will be then 360 minus sum of these two. So that angle will be given as 150. So applying then Lamy's theorem for finding the force P minimum. Suppose you are asked minimum force, then minimum force will be in place of this on this line, along this line. It will be along this line such that which is making angle 90 degree with R. So in that case, then applying Lamy's theorem, P minimum divided by sine 120 is equal to R divided by sine 150 is equal to 500 divided by sine 90, and we will get P minimum as 433 Newton. Now here, this is the case of Jib Crane. So in a Jib Crane, the jib is making an angle of 30 degree to the vertical, and the tie is making an angle of 60 degree to the vertical. if the crane lifts a load of 100 kilonewton, calculate the internal forces in jib and tie. So here this is jib and this is tie, and here weight 100 kN is hang. So we are asked to find out the nonce, that is this is tie, which is in which there is a tension coming, and this is jib in which compressive force is coming. So then drawing Freebody diagram at this point, we will have this 100 kilonewton weight vertically downward, and here in this line compressive force, but using transmissibility law we can show this force in this line as F here, like this, and in the tie tension T, that is like this. This angle is 30 degree and this angle is 60 degree. So using geometry we can find all angles, that is angle between each force. So here between F and 100 kilonewton, this angle is 30 degree because that jib is making angle with vertical 30 degree. So here with vertical this angle will be 30 degree. So remaining angle, this one, for making linear pair, it would be 150. While here between tie and jib, or say tie is making 60 degree angle with vertical. So with vertical this tie is making angle 60 degree, so it is 60. So this rest angle will be 150 then. So applying Lamy's theorem, then F divided by sine 60 is equal to T divided by sine 150 is equal to 100 divided by sine 150. So we have F equal to 326.8 kilonewton, that is nothing but force in the jib, and which is compressive, and in the tie, that is tension, is given by on simplifying 100 kilonewton. One more problem on jib crane. In a jib crane, the length of jib 120 centimeter and length of tie is equal to 100 centimeter, and the length of vertical post 80 centimeter. It carries a weight of 500 Newton. Calculate the force transferred in the jib and tie. So here, instead of angles, length of each member is given. That is in the jib crane, this is known as tie, which is given length 100 centimeter. This is vertical post, which is having length 80 centimeter given, and this is jib, which is 120 centimeter length given. So to finding the unknowns or unknown forces in the tie and jib, we need to have angles between all, that is angle between tie and post, angle between post and jib, and between tie and jib. So for this we can use cosine rule. So applying cosine rule here in triangle ABC, cosine rule, as per cosine rule, say this angle is theta 1, this angle is theta 2, and this angle is theta 3. Then applying cosine rule in this triangle, cos theta 1, which is equal to square of this side plus square of this side minus square of remaining side divided by 2 times this side into this side. So here cos theta 1 is equal to 100 square plus 120 square minus 80 square divided by 2 times 100 into 120. So using this cosine rule, we can have cos theta 1 is equal to 0.75. So which will give theta 1 on making inverse of it 41.4 degree. Same way for cos theta 2, applying cosine rule, we will have cos theta 2 is equal to 100 square, that is square of this, plus square of this 80 square minus square of this 120 square divided by 2 times this into this. So 2 into 100 into 80, which is giving cos theta 2 is equal to 0.125. So inverse of this cos we will have theta 2 value is equal to 82.82 degree. So then drawing free body diagram at point C, we will have 500 Newton force here, force in the jib, say that is P, which is compressive in the jib, and in the tie parallel to that force T. Here theta 1 we calculated as 41.4, this angle as 82.88. So this angle theta 3, remaining angle will be 180 minus sum of these two, because triangle will have summation of all angles 180 degree. Or we can also apply cos rule directly, that is for this angle finding cos theta 3 is equal to 80 square plus 120 square minus 100 square divided by 2 times 80 into 120. Or we can find theta 1 plus theta 2 summation deducting from 180, will have cos theta 3 value 55.78 degree. Then applying Lamy's theorem, T divided by and for simplicity say we are drawing a force triangle, then say we are showing this force as P, that is P, then from P we need to draw T, that is T, and then from that this force. So in this we will have angle between T, that is this line, and between P will be equal to theta 1. So that theta 1 we are knowing. Angle between T and 500 Newton, which is 180 minus theta 1 plus theta 2, because this theta 3, because this angle between 500 Newton and P is theta 3. So applying sine rule, Lamy's theorem, then T divided by sine theta 3 is equal to P divided by sine theta 1 plus theta 3 is equal to W divided by sine theta 1. So putting values and simplifying, we will get tension in the tie as 625.2 Newton and force P in the jib, that is compressive force, as 749.9 Newton. So that is in this topic, that is coplanar concurrent forces. So I took in fact 10 lectures, and in 10 lectures I discuss in coplanar concurrent forces topics like force, then laws or principles, and resolution and composition of forces. We discuss about resultant and equilibrium methods to find resultant, law of parallelogram, then law of triangle, law of polygon, then finally we discuss Lamy's theorem and we solved problems on Lamy's theorem. So in the force I discuss unit, what is force, what are units of force and elements of force, different system of forces, laws and principles, that is we discuss equilibrium law, law of transmissibility, law of superposition. Then in resolution and composition we discuss resolution or resolved components along two orthogonal axes and also along non-orthogonal axis, and then composition. And so let us have a summary of all these topics. So coplanar concurrent forces summary. First of all, we discuss force. As I discussed, it is nothing but it is defined as an external agent which changes or tends to change the state of rest or of uniform motion of a body. So force can be shown by an arrow, and in this arrow this is tail while this is known as head. So it is, and force is a vector quantity, and value of force or magnitude is given by F is equal to ma, or F is equal to W. In case of say acceleration is vertically downward or say vertically upward, then we can take this as W is equal to M into G. Or weight, we can find which weight is nothing but a force which is given by M into G. And SI units of force, we usually take SI unit of force as Newton or kilonewtons. Usually we take Newton or kilonewton, but sometimes we need bigger units also, that is meganewton, giganewton, etc. And as you know, 1 kilonewton is equal to 1000 Newton. Also, formula of Newton is nothing but kg meter per second square, because F is equal to ma. So unit of mass is kg and unit of A is meter per second square. So kg meter per second square, that is mass is taken say in kg and acceleration in meter per second square, then kg meter per second square is nothing but the unit of force, which is the basic unit, and that is Newton. Then we discuss about elements of a force. Force can be completely represented or explained or shown by means of this, that is magnitude, direction, position or location, and nature or sense. So if say this is the force, then whatever value given, say 5 Newton, 10 Newton, or whatever value which are given, which is given is nothing but it is showing the magnitude of force. Then say here angle is theta, then angle is nothing but its direction, or it is angle between line of action of force with reference to axis, any axis. So that is known as direction. And for direction we also need a concept of line of action of a force. So what is line of action of a force? It is nothing but a line contained by a force. So if you draw a line passing through this force F, then that line is nothing but a line of action of force, or it is the line containing a force. Then position or location, for in this case say we want to find out position or location, then we can see force is acting through this point, so that point is nothing but its position or location, or say line of action of that force is passing through a particular point, so that is nothing but its position or location. Then nature or sense, which is shown by arrow, and nature we can have maybe what effect is force is giving on the body or particle. Accordingly nature is discussed, or nature is determined, that is a pull or push, or say it is a tensile nature or compressive nature. So nature is shown by arrow. Then we discuss about different system of forces. So for knowing different system of forces, we need to have definition of force system. So what is force system? The way of representing two or more forces acting on a body, because we deal with two forces or more than two forces, or even a single force. Whatever is shown by the forces acting on the body or particle is nothing but force system. So it may be like this, two forces, concurrent forces acting like this, or two or more than two forces, or it may be collinear forces. So that is nothing but force system. Coplanar forces, as we discussed, if the lines of action of all the forces lie on the same plane, then all the forces are known as coplanar, means forces lying in the same plane. So here say these are the forces which are lying in the same plane, so these are known as coplanar. Concurrent forces means forces whose line of action meeting at a point are known as concurrent forces. So here it is two concurrent forces. Here forces are say 1, 2, 3 and 4. Line of action of all these forces is passing through common point O, so these forces are known as concurrence point. And common point through which their lines are intersecting is known as concurrence point. Then classifying coplanar force system, we can have two basic categories: concurrent forces and non-concurrent forces. Concurrent forces can be subclassified into collinear and non-collinear. Collinear means forces acting along the same line of action. It may be like this, means collinear and having same sense or nature, or maybe collinear with opposite sense or nature. So collinear forces can be shown in a same line like this or like this. Non-collinear means forces which are not in the same line, they are having their line of actions different, but again their point of intersection is same. So then non-concurrent forces is nothing but forces whose line of actions are not meeting at a common point are known as non-concurrent forces, and under that there will be two subcategories, that is parallel non-concurrent forces and non-parallel non-concurrent forces. In parallel, there may be forces parallel like this in the same direction or same sense. They are known as like parallel, maybe horizontal or vertical or even inclined, but in the same direction and parallel. Unlike parallel means though they are parallel, their nature or arrows are different, and again it may be horizontally parallel unlike, or inclined parallel unlike, or vertical parallel unlike. Then non-parallel category means forces which are not parallel to each other, but they are non-parallel and they are not, their line of action is not meeting at a common point. So this is the case of non-parallel non-concurrent forces. Then we discuss about laws and principles of forces, in which we discuss about equilibrium. And equilibrium, as you know, any system of forces which keeps the body at rest is said to be in equilibrium, or when condition of the body is unaffected even though it is acted upon by a number of forces is said in equilibrium, or state of rest under the action of forces is known as equilibrium. And for equilibrium we discuss about 2 force to be in equilibrium, then 3 force to be in equilibrium, and 4 force to be in equilibrium. In 2 force to be in equilibrium we discuss that 2 forces to be in equilibrium, resultant of 2 forces must be equal and opposite to the third force. In 3 force principle we discuss resultant of any 2 forces must be equal and opposite to the third force. And in 4 force principle we say a resultant of any 2 forces must be equal and opposite to the resultant of the remaining 2 forces. So that is known as 4 force principle for equilibrium. Then we discuss principle or law of transmissibility. Law of transmissibility says that the force can be shown anywhere on its line of action. That is, say on this hook, we can, if we apply force directly through this point in this line, or we can show that force in the same line here also. So force can be shown anywhere on its line of action. Anywhere, it can be shown anywhere on this line. So that is known as line of action of a force. Then principle or law of superposition. That is, a balanced force system can be added or removed from the existing force system, and doing so its effect on the body or particle remains unchanged. Say here on this body a force P is acting. Okay. For keeping effect of this force same on the body, if I add equal force system, that is say Q and equal force Q I am applying on the same line. So if I add this force system into this existing force system, then its effect will remain unchanged, because here actually 2 collinear forces nullifies its effect, because this system is already in equilibrium, so it will not disturb the effect of the body or particle. So this is known as principle of superposition. That is, a balanced force system can be added or can be removed from the force system, and doing so its effect on the body or particle remains unchanged. Then composition and resolution of forces. In this lecture I discuss about the resolution of forces, and as I discuss, resolution can be done along two mutual perpendicular axes or along two non-perpendicular axes, but mostly we deal with resolution of forces along two mutually perpendicular axes. So more weightage is being given onto this. So and along two mutual perpendicular axes, it is also known as along or two orthogonal axes, or components we got in along a mutual perpendicular axis are known as resolved components. So means to find out components along x-axis and y-axis, or along horizontal axis and vertical axis, usually needed, and this resolution usually we need in the case force is inclined with reference to, say, our two mutual perpendicular axes. Then composition. So resolution means say force F which is inclined with the x-axis and it is making angle theta, then its component or its effect along x is given by fx, which is equal to f cos theta. Cos, because we have taken angle theta and which is making angle with x-axis, so its x component would be cos, while sine component would be sine. And say if this force F is making angle with vertical, then its vertical component would be cos and sine, x component would be sine. So it depends, cos or sine, it depends with which the angle is being taken. Composition then, method or process to find a single force in place of number of forces acting on a body or particle. So this is actually reverse of resolution. So here say we are knowing for so many inclined forces we have say determined sigma fx and sigma fy. Then in place of sigma fx and sigma fy we can find a single force F with and also its angle. So this process of finding out a single force in place of number of forces acting on a body or particle is known as composition. Then resolution of force we discussed already. That is nothing but along perpendicular axis as f cos theta, f sin theta, and along non-perpendicular axis that is f1 and f2 components, and can be given by this formula that we discuss. Resultant and equilibrium. Then resultant is a single force which gives the effect of all given forces acting on a body or particle, or it is defined as a single force which can produce the same effect as it is produced by the number of forces acting together. So it is nothing but a single force in place of number of forces acting on a body. So it is and usually denoted by R. So R is nothing but its magnitude. We also need to find magnitude as well as direction of resultant force, that is alpha R. And resultant, obviously it causes the body to move, or it causes the displacement of a body. So obviously it is disturbing the equilibrium. Then equilibrium force, it is a single force equal in magnitude but opposite to the resultant force. So if resultant is R, then equilibrium force is exactly equal to R but opposite in the line to R. So R is equal to R dash, and line of resultant and equilibrium is the same but their nature is opposite. So equilibrium actually it establishes the equilibrium. Resultant disturbs the equilibrium, while equilibrium force establishes the equilibrium. Then we discuss different methods how to find resultant of given force system. Maybe two force system given or more than two force system given. So again, say two forces given as concurrent forces, and then to find resultant we can have resultant analytically or graphically. In analytical part we will have formulas or equations, and we discuss in analytical methods resolution method. Then we discuss about parallelogram equation, and then triangle law equation. So this is numerical part or mathematical part in which equations it deals with equations or formulas. While in graphical method we need to draw some figures, and from that those figures we can find resultant. So by drawing this can be done by drawing a parallelogram for two concurrent forces, or for two concurrent forces we can draw a triangle and we can find the resultant. For more than two forces, analytically there is a common method which is a resolution method, which we use in the two forces case also. So that is resolution method, and which R is calculated by formula. And for more than two concurrent forces we can solve it graphically by means of drawing a polygon or force polygon. So summarizing then resultant, how to find resultant analytically. Say we consider two cases, that is for two forces and more than two forces. Two forces, that is say two forces P and Q concurrent are given, and angle between these two forces is theta. Then to find resultant of these two forces is say R, and angle of that resultant is say alpha R with P. Then it is given by, in the resolution method we need to resolve this inclined force, and then we need to find out sigma fx and sigma fy, and then R is given by root of square root of sigma fx square plus sigma fy square, and angle of resultant alpha R in resolution method as tan inverse sigma fy by sigma fx. This of course gives the angle with respect to x-axis, and mind well, whatever angle we are getting from this is the acute angle, that is angle less than 90 degree. In parallelogram law we already derived this equation, which is R is equal to root of P square plus Q square plus 2PQ cos theta, and alpha R is given by tan inverse Q sin theta divided by P plus Q cos theta. Mind well, this gives us resultant force with respect to force P. And in triangle law also we derived this equation, R is equal to root of P square plus Q square minus 2PQ cos theta. In place of plus, which we are using in the parallelogram, here it is minus, and instead of theta we are taking angle beta, and beta is nothing but 180 degree minus theta. So we take theta in triangle law. Then angle of resultant with P is given by a sin inverse of Q by R sin beta. So this is how to find analytically resultant force for two concurrent forces. For more than two concurrent forces, as you know, we have common formula, that is resolution method. So again, say more than two forces, say forces given as F1, F2, F3, F4, and also knowing angle of each force with respect to say axis, then we can find a resultant by this formula, sigma fx square plus sigma fy square, alpha is equal to tan inverse sigma fy by sigma fx. Again we can solve this problem for finding sigma fx and sigma fy by taking all angles with respect to positive x-axis only, or taking angles separately with each particular axis. And then if you take angles separately from a particular axis, then we need to take care of sign, that is we will have to use sign for plus and minus. Then we discuss graphical methods, and graphical method is nothing but method which incorporates use of geometrical figures for example, it may deal with points or straight lines, or drawing even non-shapes, that is say parallelogram or triangle or polygon. The results so obtained by this method may tally with that obtained by analytical method if enough care is being taken. If you have not taken enough care, then this resultant value obtained in graphical method would differ with the analytical results. But even though we are using this method, if it is used if the force system is complicated, this method is the easiest method to use for finding the resultant force. And in graphical method, we need to have a concept of force system clear. That is, what is force system, then how to draw space diagram from the force system. And as you know, when two or more forces act on a body, they are called or said to form a system of force, which is shown like this. Space diagram from the non-force system, we can draw space diagram by taking angle or measuring angles exactly and showing line of action. So if forces acting in a system are represented by a direction in the form of diagram using Bauer's notations, the diagram is shown as a space diagram. That is, each force in Bauer's notations, what we are doing, we are giving two separate letters to each force on either side of force. That is, so for this force we have given separate letter A here, and on this side other separate letter B. Accordingly, we are giving these capital letters as per Bauer's. So here in space diagram, we are measuring angle exactly or distances exactly, and also the line of action we are plotting in this way. In vector, then from the space diagram we draw vector diagram. So a vector diagram is nothing but it is showing each force of space diagram or reactions in magnitude and direction. Then we also need to draw free body diagrams in some cases, and as you know, free body diagram is nothing but for a given body, if supports are removed, then and forces acting on the body and supports are removed, and if forces and reactions are shown, and then that diagram is known as free body diagram. This is how we find graphically by drawing parallelogram. For drawing parallelogram, we take these two forces as the adjacent side of a parallelogram, and then we are drawing from the intersection point diagonal. So that diagonal gives us the resultant force. And in triangle, we are taking two forces in sequence as per its magnitude and direction. Then the third side of triangle gives us resultant force in magnitude but opposite in direction. And in polygon, we draw a force polygon taking each force as per its magnitude and direction, and then closing side of the polygon gives us resultant force, but its direction will be reverse. Then we also know the statement of each, that is parallelogram law, triangle law, polygon law, or then we also discuss equilibrium, then conditions of equilibrium, that is for concurrent forces to remain in equilibrium. Analytical conditions are sigma fx of all the forces must be equal to 0, and sigma fi also must be equal to 0, or in short, resultant of all the forces must be equal to 0. Then and then force system is said to be in equilibrium. So these are the two analytical conditions for concurrent forces to be in equilibrium. Sigma fx is equal to 0 and sigma fi is equal to 0. For graphical conditions for concurrent forces to be in equilibrium, if two coplanar concurrent forces acting for equilibrium, they must be equal, opposite and collinear. That is, no parallelogram or triangle possible to be drawn. And if more than two forces, we will not get polygon unclosed, but we'll get force polygon closed. So this is what the graphical conditions are. And finally we see Lamy's theorem, and in which we see the statement of Lamy's theorem, its proof, applicability, limitations, and problems, or applicability, in which cases we use this theorem and we can find the unknown forces. So Lamy's theorem, as we discussed, it is nothing but if three coplanar concurrent forces are in equilibrium, then the ratio of each force and the sign of the angle between the other two forces remains constant, and this can be used for three coplanar concurrent forces in equilibrium. So this is all in this topic, that is coplanar concurrent forces. I think you are now very much confident of this topic, and as you know, this topic is having weightage about 25% in this subject, applied mechanics. So then I am saying thank you to all, and I am confident that you are now very much aware of this topic, and you can solve any question or problem related to this topic. Okay then, thank you.